Power to the Truth. This is Monday, August 13th, 2018, and this is Margo. And we're going to do an Arctic sea ice update today and also cover some other breaking events that are happening in the Arctic. We're going to start out with the earthquakes that have happened in the last couple of days. The first thing that happened was an earthquake right up here in the Arctic Ocean that happened on August the 11th at 11:27 Pacific time. Yeah, I've got this set for my time zone, which is UTC -7, so Pacific time. And I've got the coordinates here. It was 10 kilometers deep, and it measured a 4.2 with the USGS. I've got the USGS website up here with all of the earthquakes in the last 7 days for us to kind of get an overview of what's going on in the Arctic and also in Alaska. So that was the first thing that happened. And then the second thing that happened was this whole swarm of earthquakes that have happened here in Alaska in the last 24 hours or so. And they can't figure out why this is happening because these are not on a tectonic plate that's moving and stuff like that. But there have been numerous, I've got them all they're all listed over here. Numerous earthquakes, all in the same area. Large aftershocks. The biggest earthquake, I think it was a 6.5 or 6.4 that happened near Katovik, Alaska. So it's right up here in this region of Alaska. And if we zoom in a little bit, we can see this whole cluster, and it's not just here, but this whole region as well. And we know that Alaska has been heating and releasing a lot of methane from the permafrost, but there is something else going on up there that I wanted to share with you today as well. You can see these red earthquakes are above 4.5, all of these red ones, but it's just been, I don't know if it's been hundreds or how many, but it's a lot. And even up here in the Arctic Ocean off the coast, meant to go in there. So this is quite interesting and disturbing, but I have a picture that I want to share. This has to do with methane hydrates, and this was some part of some information that was sent to me by one of my YouTube subscribers, and he just wants to be known as Mark from the UK. And I started looking at methane hydrates and drilling and stuff like that, and I briefly presented it a few videos back, and no one commented on it. But this is serious business, and this is a map from 2009 that was part of a PDF file somewhere. I'm not sure exactly where it came from, but it's, let me get back to this. This map shows in recovered gas hydrate is yellow, where they're actually drilling and recovering gas hydrates, which is methane. And this map is from 2009. And the red dot is inferred gas hydrates, meaning that they think that there's quite a bit of gas hydrates and worth exploring in the future. And so why I brought this picture up is to show you the location of where they have already been taking out these gas hydrates, which is consists primarily of methane, and how it relates to where we're looking at in Alaska. It looks like the same area to me, frankly. It just looks like the same area. And I know that the deniers are going to say, oh, well, that can't cause an earthquake and this and that. But we do know that fracking does release methane. And Dutch Sense also has showed time and time again where earthquakes have been very near operations where they've been fracking and drilling down into the earth. And so I don't discount any of this. And you can also see that even in 2009 they were finding these pockets of the hydrates, which equals methane, because methane is like 90% of what they're going after in these hydrates in a frozen state or a cold state that they can manipulate and extract, and it'll be easier for them to get out of the earth. So, there's that. So I just wanted to show that right up front, because we are looking at some very unusual activity. Sam Carana has said in a Facebook post that he thinks it's from the melting permafrost causing these numerous earthquakes. But you can see these earthquakes are all across Alaska. This is in the, what did I set up? I think it was the last 7 or 30 days, 7 days. I can't remember what I set up the parameters to be, but it's all across Alaska. There are earthquakes happening. It's a highly geologic active area. And also in the Arctic Ocean, I haven't done much on this, but this is a highly active geologic area. Also, underneath the Arctic Ocean, there's an area called the Gaggle Ridge, and it's like a mountainous area underneath the Arctic Ocean that goes all the way across, and there are volcanoes under there and active geologic things happening there. So I think this is going to happen more and more as we get into this melt season and into the losing the sea ice. Granted, the sea ice is floating, and so that's not shifting plates when that melts. But we also have shifting of the weight on the tectonic plates when the permafrost melts, and also when the glaciers melt. And Greenland is under a lot of stress right now because it's much warmer than usual, and there have been many reports on the Greenland glaciers melting. And so as those glaciers melt, that's releasing pressure off of Greenland, which is a huge area. And also you have melting permafrost all across Alaska and Canada, and so that's going to be releasing pressure as well. And we also have lots of melting permafrost in Siberia, and so when the weight is released on one plate, on one part of the world, it affects the other plates, and they'll move up and down and back and forth, and it creates this activity, and it releases pressure. So the next thing we're going to look at with our sea ice update is the NASA World View. I already have it up. The data is not all in yet for today, the 13th. We can see we have quite a bit of missing data here. So we're going to look at yesterday's date, the 12th, because we have all of that data in. And the first area we're going to look at is where that earthquake occurred in the Arctic Ocean. So just to see, this is going to be an area that we will be watching to see if there's more breaking up and cracking in the sea ice as a result of this earthquake. Now the coordinates were 81.312 north and 118.056 west. And our coordinates show up down here in this right hand side wherever you move your mouse. So 81.312 north, 81 point I'm gonna get 81.31 is what I've got. Excuse me. And then 118.056. So I'm going to go east a little bit. Nope. I'm going to go west a little bit. Well, no, yeah, I need to go east. 118. Got to adjust this. Okay, there's 118. And then I'm going to go down for 81. Well, it's going to get hard to get it exactly right. I'm going to pause this while I get this. I'll be right back. Okay, I'm back. It's going to be about in this area where I have my pointer. And so let's zoom in there. And we'll see what we can see. We have a little bit of cloud cover. And we can see through the clouds that we do have some breaking of the sea ice here. So I expect to see more breaking up, because when you have an earthquake like that, it will shake things up. So we can see that the sea ice is breaking up in that area. So while we're here, we're going to go ahead and look at, so that's about in this area, somewhere around in this whole area, I'm thinking is what we're going to be looking at. And it is starting to deteriorate. It's within that 80-degree circle north latitude. And what we're seeing here, we've seen more deterioration on the east side this week, and we're also seeing more melting around Greenland, especially on the northern part. And this is where we used to have that thick multi-year sea ice right along in here, and that's starting to melt. And I'll zoom in a minute on this. And then we've had further deterioration of the sea ice up on the northwest part, and it's fallen away here as well. Let's look, and I'll come back to this NASA World View in a moment. I want to hop over to Climate Reanalyzer. Now, we're focusing on the Arctic, and here's the average temperature for today. Here's our maximum temperature. We can still see that the temperatures are above zero over most of the Arctic, and then minimum is where it goes when it's not as warm. And the Earth is starting to tilt. The North Pole is starting to tilt away from the sun as it's moving on its journey away from the summertime into fall up there. Now here's our 2-meter temperature anomaly. We can still see that above the North Pole, it's above what it should be. Greenland is above where it should be, and also in the Arctic Ocean, it's much hotter than it should be, 10 degrees Celsius, and Siberia, it's still much hotter than it should be. And also over this area next to Novaya Zemlya. And you'll also see when we get to our sea surface temperatures that the sea surface temperature is much warmer coming in from the Atlantic and from the Pacific, and that's also warming things up. Let's look at our current precipitation. It's raining over the northern part of the Arctic Ocean, and it's snowing a little bit down here. And on Earth Null School, I don't have it pulled up, but I did see that we're being set up for another system that's going to be coming in around the 15th, and it's going to be circling around. I'm not sure how wet that's going to be, if we're going to get rain, if we're going to get snow, what the winds are going to be like up there. But if we do get a system that dumps a lot of rain, that sea ice is just going to go. It's going to go really fast. So let's look at the snow cover here. We can see a deterioration since our last report over here, and going in more on the edges. Here's our sea surface temperature. It's all above zero, even coming up to the ice. It's pretty much above zero. And then our sea surface temperature anomaly. Now here it is where it's coming in from the Arctic, and it's much warmer than it should be, and so when it's coming into contact with that sea ice, it's just melting. And the sea ice is melting from underneath as well, and it's a real bottleneck here coming in from the Pacific, and it's much warmer than it should be. So this whole area where we see that collapse in the sea ice on the left side in the Beaufort Sea, we have warmer sea surface temperature And also here where this East Siberia ice shelf is much warmer, and all around the coastlines. So we're going to be watching those as well. So I'm going to go back to the sea ice cover. Now I'm going to go back to this viewer here. And I want to show you, I'm going to do our slideshow like where we've come in the last 7 days. Okay, from Monday, August the 6th, this was Climate Reanalyzer on the northern hemisphere. And we can see it start deteriorating. Here's the 7th, the 8th, the 9th, 10th. And on the 10th, you can see it got a lot darker, meaning it's losing integrity. The sea ice is losing integrity. Here's the, did I show the 11th? Friday the 10th. Here's the 11th and the 12th. And here it is from today, the 13th. And we can really see it starting to lose integrity here. So there's that. We also have, here's the Navy sea ice thickness from today. We can see that it's much thinner even today. And here's the Navy animated GIF projected into the next 7 days. This is from today off of their website. And I can stop this in this Honeyview viewer, and let's go back. Here we are today, and we can see that according to this Navy website, how much it's melting north of Greenland. And now I'm going to hop back over to the NASA World View, and we're going to zoom in to this sea ice and really get a good look at it. Especially this north of Greenland, because this, I was looking back in the previous years and I've not ever seen it melted like this around this coastline. And we can go back at the previous years and look as well. Now we are dealing with some cloud cover here today. So let's go back and see. There were fewer clouds yesterday, so we can see a huge deterioration of the sea ice north of Greenland. We can see the edge where it's really breaking off and melting. That's as close as I can go in. So this is quite a bit different than previous years. And now let's just go back to some previous, and we can see it even melting over here more all around that Greenland coastline. So let's just look back to 2017 and see what we can see, and see if we can compare the sea ice from 2017. And we're looking through a few clouds, but we can discern that the sea ice was much more intact last year. This was August 12th of 2017. So I'm seeing a huge difference in the way the sea ice is melting this year. And you can see that it was more solid even around the eastern side of the coast of Greenland here. And it was not melting as far inland. We see snow cover closer to the edges of the actual Antarctic, not Antarctic, Greenland. I'm sorry, I'm still kind of half asleep this morning. So let's go back to 2018. 1948. How did that happen? That's not going to load. Talk about time warp. Mandela effect there. See, we can see much less snow here on this northern part, and on the eastern part too, and on the western side. It's really, the interior of Greenland is really starting to heat up and melt. We can see the edge here. So this is quite distressing. So the melt season is totally different this year in that it's much warmer and melting this multi-year ice. And I do believe that we are going to see a blue ocean event. I really do believe we're going to see it this year. You can see it's lost its integrity here. We're just zooming in at different places. And here's where that's all broken up in the Beaufort Sea. Here's Alaska over here. And then here's Siberia over here. And you can see how it's just come all the way from the coastline. We'll zoom, we'll go, here's today. I went over to today. This is cloud cover here. You can see the difference between the cloud cover and the sea ice here. Sea ice is the larger chunks. And Guy McPherson does believe that we could hit the blue ocean event in early September. And remember, that does not mean that all the sea ice is gone. It means that it's down to 15%. And blue ocean event means that the ships can travel without having an icebreaker. And this ice edge is well within the 80-degree north latitude. That's at 82.7 where my cursor is there. So here's 83.37. So it's melting a lot more on this eastern side than we've seen before. And it's hard to tell between the clouds and the snow and the ice exactly where we're at with some of this. So that's why we look at different models as well. That looks like clouds. That wavy stuff looks like clouds to me. But it does looks like we're looking through to ocean coming through here and here and here and here as well. It's just hard to tell, but we'll be able to see more in the next few days how this is progressing. Actually, that does look like ocean to me. That's at 85. Oh my gosh. Why'd I not seen that before? So it really is melting much faster now here above Canada. There's a huge break there. Let's look at Climate Reanalyzer. Yep, they're showing that here. And let's look at this navy. It's hard to tell there. It's from today. Right, it's right along that edge there. So it looks like it's this is some older, thicker sea ice, and this is where the edge of that is. Now this is new. We haven't seen this before. This is really fast. And it's breaking up, sorry, it's breaking up over here too. Let's look at yesterday on that area. So we can't see that area because the cloud cover. This is what I'm talking about, how it's hard to see exactly what's going on because the cloud cover some days. But here it is. There's not much cloud cover at all. It's just little tiny wispy clouds that we're looking through. But that looks like that's gone. That is definitely gone. And that's at 86. 86.442 over here degrees latitude, and then it's melted more over here. That's at 87, so it's getting a lot closer to the North Pole, a lot closer in. That's what it looks like. So this is why we have to keep looking at this very closely, because some days the cloud cover is going to be less than other days. And here it's kind of hard to tell because the way these satellite images come in are in sections. And so from one section to the next, there's not a good transition. So it's hard to tell what's going on here. Looks like a ridge here. That's as close as I can zoom in, so I don't know what kind of ridge that is. But it definitely looks like blue ocean here, all the way down. And that's new today, and here going in. Wow. Then we've got more melting over here on the west side as well. That's all gonna go very soon. But this is the most shocking to me. I'm kind of speechless here. I know I need to move on, but this is, I'm just kind of speechless. And we can see it really breaking up here too. So this whole area above Canada is really, really fragile. And Greenland. Canada and Greenland. I was really not expecting to see this today. I hadn't looked at any of this till I got on and started recording. So Robin, when you see this, I'm sure you're going to have something to say. Look at this. So we're watching it. We're watching the demise of the sea ice. We're documenting it. We're documenting this melting, this epic melting in the Arctic. Documenting it right here. No one is reporting on this. It's just not being reported on. Where are the other climate scientists reporting on this? I don't see it anywhere. Guy McPherson, but he doesn't do much research anymore. He's mainly doing social commentary. No one's reporting on this. Let's see if any of this is, if we can see this on the 13th. No. Look how the clouds have covered that up. You can't even see that. But you can see how it's melted all the way around Greenland right along here. But that huge area, well, here it's coming through. We can see it, but you have to really know what you're looking for because it's covered with a lot of clouds here. So we have to keep looking every single day very closely. And it looks like it's breaking up even more around here. Wow. This is incredible, folks. This is incredible. Look at this hole. That's as close as I can go in. There's definitely a hole there. There are holes over here. I can't tell. There, I can't tell if that's shadow from the snow I know we might be seeing some shadows now that the North Pole is tilting back away from the sun. So some of these might be shadows. But when we can zoom in and see chunks of sea ice, and we can zoom in and see the ice breaking up, that's not shadows. Oh my gosh. This is not shadows here. That's at 87 latitude. This is all at 87. So, I will leave the links below and you can look for yourselves. That's at 88. You know, you can decide for yourselves. Some of that does look like shadows, but some of it does look like it's really breaking up. It's just hard to tell. But when we go back to yesterday, we can see this is not a shadow. This round area is definitely not a shadow. That is ocean, blue ocean that you're seeing through there. Through these holes. And the sea ice is so thin, you can see the ocean through it. That's what you're seeing there. Oh, I didn't mean to go back to July. Anyway, I'm going to leave this. It's acting crazy. So, now we're going to make the rounds through the other websites and we'll wrap this up. This is from Arctic Sea Ice News and Analysis, National Snow and Ice Data Center. This is Sea Ice Extent. This is from yesterday. They're not showing the holes here like what I just saw. I just don't think their modeling is that accurate. Here's the concentration. And we can see it's bluer, which is less concentrated. Let's see if they're showing that at all. You know, they're showing it a lot less concentrated around Greenland here, but they're not showing the holes. It's just not being reported on. And, you know, seeing that satellite imagery, I think is the most accurate that you can get. Here's Antarctica. They're still building their sea ice in the winter, but they got a little hole going in there. And their concentration is about what it was last time, it looks like. So as we go into fall, we'll be more interested in the Antarctic sea ice. And we can see that that's about the same as last year. So there's that. And we saw the Navy. Now what I want to show you something. Let's look at, since we're comparing years, let's go to the snapshot archive. Let's look at where we are from right now from last year. Let me go. I've got in 2017. Snapshot archive. Okay, here's 2017. and I want August, and I want the 12th. Let's get this most recent data for the 12th of last year. Now this is from August the 12th of last year. Let me pull up this, make it less. And here's the 13th. So this is the melting of what we're seeing. Let me actually get August 13th. Here it is. And let's look at these side by side. And we can do a comparison. Okay, so we're in the same system, the GLB, which is the newer measurement system by the Navy. And this is from August 13th of 2018, which is today. And this is from August the 13th, 2017. And so we can see a different pattern of melt. Now notice how last year there was more sea ice towards the edge of the 80-degree north latitude. That's that circle there. But here it's melted so much further inward from 80, the 80 north is cut way in this year. Also, we're noticing a huge amount of melt on the coast of Greenland, and the pattern here is we have more sea ice extending to the west of the North Pole. It melted more on the west last year, but it's coming in at about the same area down here by Alaska, but we've seen a greater melting of the multi-year, the thicker ice here. And it was about the same thickness as far as where it was extended. It was about the same thickness as what we're seeing. So let's go back just for the heck of it. Let's go back to 2016 and see where we're at. Now we're still in the more modern system. We want to stay in the GLB system in order to have a more accurate analysis. Okay. Now, here's GLB, and you can absolutely see the huge difference from 2016. This was August the 13th on 2016, and here we are August 13th, 2018. And you can see the thickness where it was extended is about the same, or maybe even a little bit thinner. There's more purple, but the thicker multi-year ice was much more prevalent, and we can see that that's very little. So that's the problem. And when that goes, then we will get that 15% volume or concentration, and that will be the blue ocean event. I think we're going to hit it this year. If not, it's going to be so close that we might as well have hit it. We can also see that in 2016, I'm going to enlarge this a little bit, the ice was close up to the coastline here in Greenland, and it was some of that thicker ice. And that's gone. That's already gone now. So there's that. So let's move on. I'd also like to show you sea ice concentration. There it is today. The concentration is much less. As you can see, we're seeing more yellow, especially here on the edges, and more down into the blue, which is much less concentration. And then we've got this yellow orangey where it's about 75% to 80 concentration. We can also look at the speed and drift, and we can see that it's going into two different directions here, and that's going to help pull that sea ice apart. And we can see also a difference in the way the ocean current is moving here. Now that's where we saw that big hole. The ocean current is pulling it open. So there's that. And sea surface temperature, we can see it really well here, how much warmer the sea surface temperature is. And especially coming up from the Atlantic and the Pacific. So we're going to leave that now. And now we're going to go over to cams. And I want to show you the methane that's coming up in the Arctic and also in Alaska. And remember that we've seen a lot of methane coming up in Alaska, and whenever they do that drilling, it releases lots of methane, a lot of methane. Our base time goes back, we have 3 days, Thursday, Friday, Saturday data. And so after the 11th, it goes into the forecast period. So this is, and the area I chose is the Arctic. Actually, yeah, we can see that. We can watch that. And the level is surface level. And it's methane at surface level, and all the reds are getting very high. This brick red is 2040 parts per billion, and then this dark brick red, they say 75,600. I don't know if that's totally accurate, but that's what their chart says. So we're going to run this movie now. We have to let it load up. Time is short. Time is very short. I suggest everyone get their spiritual houses in order. We talked about that in my campfire chats last Thursday and the climbing of the ladder of awareness. I would like to just go on the inner journey, the inner path, but I know that I've chosen an outer path as well to help show people as we're progressing closer and closer to the end, and also to help them deal with their emotions and how to prepare as best they can, spiritually, emotionally, and all of those things. So we can see a lot of methane being released here. It's just covering this east side of the Arctic Ocean as it's coming up from Novaya Zemlya, from Siberia, and then the East Siberia ice shelf, the East Siberian Sea here. We can see it coming up from Alaska. Now, I don't see huge levels of methane coming up where those earthquakes were. That doesn't mean anything, though, because, you know, sometimes the earthquake activity happens after all that stuff is released or melted, or it can be a precursor of other things that are coming. So we can see that this Arctic area is really being covered up by methane. And is totally adding to the higher heating of the Arctic area, Arctic region, 3 to 5 times faster than the rest of the world. So my name's Margo. My website is margoshealingcorner.com. I'll do a climate cast update in the next few days, and we've got to keep an eye on this sea ice. I love you guys. Go in peace. God bless everyone. Goodbye.